drink us. That's the good news. If you miss it again, we can still make it up after Thanksgiving. We have a few weeks until Christmas. You can make it how it happens. You are that good. I probably won't type in the zeros over Thanksgiving break. I'll probably give you that full week before I start going zero crazy again. But at the same time, the sooner I type in a zero, the sooner Lena remembers, hey, I need to go fix that. So I don't know. You know what I mean? I don't know. Okay, moving on. So we've got some stuff next week. But if you're not here, you will be able to get caught up. And I'm going to use all my words now so you don't miss out on any important, meaningful words. Let's start with our math workshop. We're on number 17. I know you don't know who Alonzo or Ada are. I know you don't know how to complete the square. However, we can still be smart enough and figure this out. What line number did they disagree on? 2 gets an extra point. Look at the third line down. Life went different on that line. One of these 2 people is correct. One of them is wrong. And whoever made a mistake made it on the third line. Who made the mistake? What did Alonzo do? Well, he's got a plus 16 on both sides. What did Ada do? She only added it on one side. Okay, and this is not something you and I normally do. We understand, like, if we're solving a problem, we understand, like, if 2x equals 4, to solve that, we divide both sides by 2. So very rarely do we find ourselves trying to add numbers to both sides. But I can. I can add 2 to both sides. So 2x plus 2 equals 6. 2x equals 4. X still equals 2. I can add a number to both sides if I want to. Do we normally? No. Are we going to do something weird that involves that today? Yes. So technically, Alonzo is right. Because what he did to both sides. So even though you're like, why is he adding 16? But he did it to both sides of the equation. Because in math, as you know, if you do it to one side of the equation, you need to do it to the other. So that's why Alonzo is right. Are there any questions on 17? Then let's go to 18. It says to solve by graphing and then solve algebraically. I'm going to solve algebraically first. So it says negative 2x plus 2 equals 3x minus 3. Add 2x to both sides. Negative 2 equals 5x minus 3. I add 3 to both sides. 5 equals 5x. I'm going to end up getting x equals 1. Okay, but not only do they want us to solve that equation, they also want us to graph. So we're going to graph 2 lines. We're going to graph y equals negative 2x plus 2. And we're going to graph y equals 3x minus 3. What do we expect to see once we graph these 2 lines? Where should they cross? They should cross at 1. Thank you, Brady. You can have an extra point. We spent a whole, now we didn't do systems like this, but we spent a whole chapter, or a lifetime it felt like, on systems. And if they cross, that's where the solution was. So if the solution is 1, they better cross at 1. So 2x plus 2, I go up to 2, up 2 over 1, up to, oh, it's negative 2x. I'm stomping 3. Down 2, right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. Up 2, left 1. Okay, so I've graphed one of my lines. I've graphed this one. Still need to graph my other line. It's 3x minus 3. So I put my intercept at negative 3. Up 3 over 1. Up 3 over 1. 3 over 1. 1, 2, 3, left one. I graph that line as well. I connect my dots. Terrible job graphing, but it'll be okay. And lo and behold, my lines did cross at 1, at 0. So x was equal to 1 when they crossed. Now, is that a weird way to solve that problem? Yes. But does it show that systems and their solution really do match the solution we get when we solve algebraically? Yes, it does. What a weird problem. Speaking of weird things, let's go to your new packet. Okay. So far we've been stuck on quadratics, and sadly we're still stuck on quadratics. We're stuck on quadratics all of chapter 4. The thought is, if we really truly understood quadratics well enough, we could take what we understand with like y equals x squared and apply that to x to the third, x to the fourth, x to the fifth, so we can apply everything we've learned about quadratics to any other type of function. And that's why we stay stuck on them for so long. You still need to know all the things you need to know for the test you just finished, or hopefully you're close to finishing. You still need to know how to graph it, how to interpret stuff from the graph, how to factor, how to use a complex number. You still need to know all those things in order to continue to be successful in chapter 4. So if you've been struggling, you're going to have to get it together, rewatch a YouTube video, do something, because it's not going to get any better. In fact, so we've been talking about graphs. How many times can a parabola cross the x-axis? 2, 1, or 0. And we talked about how to factor and to see a 2, a 1, or a 0. And today we're still going to see 2, 1, and 0. So basically we're going to have this whole toolbox of ways we can deal with a quadratic problem, how to solve it. We already know how to solve it factoring. We kind of sort of understand maybe complex numbers can help us solve. Today we're going to learn how to complete the square and solve. And then part of tomorrow and Friday we're going to learn how the quadratic formula can help us solve. If you're a terrible memorizer, I highly recommend you go home and look up a quadratic formula song. I might sing you one tomorrow or Friday, but I'm no Britney Spears or whoever your person is now. I am not that person. But you need to know the quadratic formula in order to keep being successful in math class. In fact, I love the quadratic formula. I love it so much. I don't factor. I don't complete the square. If I get to choose, I use the quadratic formula every single time because it never lets me down. But sadly, you're in math class, so in the real world, on like an ACT or feature math question, you get to do your own thing. I would quadratic formula it. But on my next test, you know it's going to say, solve this by completing the square. So if you don't complete the square, you're not going to get your points. It's like that substitution and elimination test. If it said solve by substitution and you solve by elimination, you did not get your points. You have to do what the directions say. Speaking of directions, you might want to add this, because this is our thing from here on out, with both completing the square and the quadratic formula. No decimals. I don't want your decimal answer. Nobody does. Instead of a decimal, you better give me a fraction. We're going to remind you how to get fractions from your handy-dandy calculator again today. But I promise you, I will know that the decimal people, well, that they haven't been paying attention, because there are some things that decimals just can't help us do. No decimals. Yes, sir.
I feel like you're targeting me.
No.
I feel targeted.
No.
You know I love decimals.
Well, you'll see on number 2 in just a minute why we can't use the decimals. Okay, we're going to start with number 1. I'm going to explain what completing the square is, but let's talk about the word square first. What do we think of when we hear completing the square? You're the first person who said that all day. But you and I both know this is not geometry, so that is not what I'm looking for. But I appreciate that. When we say square, I'm not meaning geometry square. What do we mean in Algebra 2? Like square root, or x squared, or we mean perfect squares. Yes, that's what I'm thinking. Yes, that's what I think of. Although, should you automatically think of a box with 4 equal sides and 4 equal angles? Probably so, but you know. Okay, so we're somehow wanting basically to make this into pretty factoring. We're going to abuse it and twist this problem how we want it to make it a pretty factoring thing, to Completing the square means make me factor and make me factor very pretty. Okay, so first thing we're going to do is move the 11 over. So I'm going to have x squared plus 10x equals 11. The first thing you do on a completing the square problem is move the number to the right-hand side. We don't want him. He's not part of our plan. Move him over. The next thing we do is we try to think about what number, kind of like that weird math workshop we had today, what number could we add to the left, and therefore we have to add to the right, that would end up making this a beautiful factoring problem, like x plus something squared, a beautiful, perfect square. And we're going to complete the square and make it into a pretty factoring problem. Man. You don't have page 21? Come get one off my desk. You have an extra one, Travis? Okay. Thank you, Travis. Okay, so we're trying to think of some number that we can put on this side. This mystery number. And hopefully this mystery number is going to make our factoring easy. Now, I'm just explaining the process. Of course, we're going to follow a simple pattern every time. Yes, dear. Say it again. No. So what we're going to do is, I'll even tell you this, we're wanting this one to be x plus 5 squared. If you knew that we wanted this to be x plus 5 squared and we were to FOIL this back out, what number is missing on that top line? You can have a 0.3. Okay, so again, for those of us who, it is Wednesday, if we were to FOIL this out, we would have x squared plus 5x plus 5x plus 25. So if only we had the 25, we would look like that. This top line would look like what we've just FOILed out. So that's why we're going to add 25 to both sides. And 11 plus 25 is 36. And yes, I am going to solve this bad boy, but not right this second. For those of us who are like, I don't know where 25 came from, and I don't understand why you came up with that, and I cannot come up with that on my own, it's really fine. There is a process every single time. It is always the middle number, so the number next to the x, it's always your middle number, divided by 2, and then squared. So if you want to write at the top, middle divided by 2 squared, that is the key to the puzzle today. So again, back to our problem. Let me zoom out on all the things. Back to our problem. Our middle number, the number next to the x, was a 10. 10 divided by 2 and then squared. That's how we got the 25. It's always middle divided by 2 squared. Okay, so we're going to solve number 1, but let's go ahead and get number 2 ready to roll, or number 3 ready to roll. Okay, God bless you, and we're going to deal with the fractions, Travis, and you can have an extra point for asking that, and no one else is going to remember this, so they'll get an extra point in a few minutes too, but yes. We're just going to fraction it, Travis. Okay, so let's go ahead and set up number 3. I move that 65 over. So I have x squared minus 8x equals 65. I'm needing to figure out what this mystery number is that I'm going to add to both sides. So it's going to end up being a pretty factor. And it is going to be a 16. Because again, you took your middle number, which was negative 8, and you took negative 8, you divided by 2, and you squared it, and you got 16. Okay, are there any questions about how we're getting that mystery number? Okay, well, I told you every time it's middle number divided by 2 squared. Every single time, middle number divided by 2 squared. Notice when we do middle number divided by 2, that ends up being what goes right here on the next line. For instance, on number 1, our middle number was 10. 10 divided by 2 is 5. We put 5. On number 3, our middle number was 8. 8 divided by 2 is negative 8 divided by 2 is negative 4. Notice our number we put down here is negative 4. So the number I get before I square it is the number I'm putting on the next line down every single time. Okay, are any major questions about how we set up these first two? 1 and 3. Middle number divided by 2 squared is how we're figuring out what we're going to add to both sides. Okay, so again, middle number divided by 2 squared gives you that thing, which we add to both sides, because you have to do it to one side, you got to do it to the other. But the reason we're doing it is because just middle number divided by 2 ends up being this pretty thing. And like when we did on number 1, when we FOIL it out, we actually get our top line. So on this one, if we actually FOILed out x minus 4 squared, we would get this line, x squared minus 8x plus 16. Okay, but we're not done. You knew we weren't done. We actually need a concrete answer of x equals 3, x equals 2, that kind of thing. So we've got to keep going. Are there any questions about this before we keep going? Because if you can't get to here, the keep going part's easy, but if you can't get to here, you got a problem. Okay, so let's solve for x. First things first, we've got to take the square root of both sides. In order to kill off that square, we've got to take the square root of both sides. Now I have x plus 5 equals plus or minus the square root of 36, which, yes, you're right, it is 6. So if you want to go ahead and jump to the 6, you can. Now, just a reminder as to why it's a plus or minus. It's always going to be plus or minus with quadratic. In fact, we're expecting 2 answers for the most part. But it's because we're not sure if it was the square root of negative 6 squared, or the square root of positive 6 squared. We're not sure. So that's why we do the plus and minus. Okay, so when in first period said, we're done. I said, no, we're not. X is not by itself. We're not done. We have to subtract 5 from both sides. So we have x equals negative 5 plus or minus 6. And then we can still keep solving. We can do both of those things. We can do negative 5 plus 6 and get 1. We can do the minus 2, negative 5 minus 6, and get negative 11. So our answers are 1 and negative 11. So again, we figured out some mystery number to add to both sides. So we can make that pretty, we completed that pretty square. Now we've solved and we have our 2 solutions. And while Abby Grace has to solve by completing the square if it says to, never am I ever taking the graph calculator away from her. So if Abby Grace is questioning her own sanity at this point, could she graph y equals x squared plus 10x minus 11 and make sure it crosses the x-axis at 1 and negative 11? She sure could. So you can always check that your solutions are correct by graphing, and did your graph actually cross at those 2 spots? Okay, are there any questions on number 1? Okay, let's go back to number 3. Number 3, we were to here. I'm still going to take the square root of both sides. So I've got x minus 4 equals plus or minus that square root of 81. But I know that's 9, so I can go plus or minus 9. If you'd like to go straight there, you sure can. I need to stop using that color. X minus 4 equals plus or minus 9. So x equals 4 plus or minus 9. But we can do both of those. We can do x equals 4 plus 9. We can also do x equals 4 minus 9. We got 13 and negative 5. Perfect. And again, if I graph this on my calculator, it's going to cross the x-axis at 13 and negative 5, or else I've done something wrong. But once we've seen the process, we're following the same steps again and again. So it shouldn't matter what problem it is, which should be good. Once we've seen the couple I get, you've done 2. Like, you need to do like 5 or 6 more. But once we've done a couple of them, like, it's the same pattern. And I hate to break your hearts, but I'm going to go on my notes. And my number 1 and number 3, I'm going to put an E. What do you think the E stands for? Yeah. So I get this was your first go round, so those did not seem easy. But compared to some of the others that require a little more thought, that is going to be an easy. Okay. Travis said something genius that I don't think we were all on his planet when he said it, so let me catch you up to Travis's planet. Why did I do number 1 and number 3 and skip number 2 originally? Yes, whoever, I was looking for even numbers. So the 10 was an even number in the middle. 8 was an even number in the middle. 13 is not an even number. Negative 13 is not an even number. So why am I not going to touch 4 or 5 today with a 10-foot pole? The leading coefficient, I heard Jessica say the term first. You can have an extra point. The leading coefficient is not 1. So we're going to say 4 and 5 for tomorrow. They're not hard, but you can see why we're going to save those. That's going to be tomorrow's problem. I'm going to go to number 6 now. Yes, dear.
Oh, I see what he's
Negative 1, yes. If you put 13 and negative 5 together, it's positive 8, and B was negative 8, and a negative 11 plus 1 together is negative 10, and the answer is, the middle was positive 10. That's completely true every single time. That's a good pattern to notice. You can have 2 extra points. Do you have to notice that? No. I didn't even notice it until today, Landon. It's like mind-blowing to me. 13 minus 5 is positive 8, and the middle term in our problem was negative 8. And then on our first one, negative 11 plus 1 is negative 10, and our term was the opposite of that, it's positive 10. Did I even realize that until right now? No. D. D. Okay, let's go to number 6. Why do you think I'm going to number 6 next? Yeah, 5 has 3 as leading coefficient, but why 6? Why 6 over 2? It's got that even middle, yes. 3 and 4 can have an extra point. Okay, originally, you got to get back on track with me. We still got a lot left to do. Originally, I was going to say, y'all do number 6 for homework. And that would have been really ugly of me, because it actually turns out number 6 is a median. Let's work through number 6 and see why it's a median. Can someone help me set it up?
Imaginary number 16.
Okay, I'm satisfied with my explanation already. Caitlin, you have 2 points. Okay, Travis, thank you for helping me set it up. You can have an extra point because you are awesome, but Caitlin already got straight to what I needed. Everyone understands this part. I move the number over. I'm needing to add something. I take my middle, divide by 2, and then square it. So the number I'm adding to both sides is 16. 8 divided by 2 squared is 16. So I'm adding 16 to both sides. This part should be good. Is everyone good here? The problem is this. It equals a negative 6. That darn negative 6 is about to be in our way. So if you're good here, we're still going to take the square root of both sides. She's already answered it. I know what you're going to say, but she already handled it. It was in the problem originally. It was positive 22, and I moved it to the other side. 5 can have a point. But Caitlin's already all over it, yeah. Okay, so we took the square root of both sides. I just have x plus 4 equals plus or minus the square root of negative 6. But you and I both know anytime you see a negative under the square root, you need to start using I. So really I have x plus 4 equals plus or minus the square root of 6i. I had that square root of negative 1. It is I every time you have a negative under the radical. If you don't suddenly involve I, you're not going to get all your points. Okay, and then you subtract 4 from both sides, so negative 4 plus or minus the square root of 6i. Literally, that is the answer. That is what we want. Now, if you want to be fancy and separate them and say -4 plus square root of 6i and -4 minus square root of 6i, you can. But to me, I'm lazy. I would rather just do the plus or minus. No. No. Now let's talk about what people do that get on my nerves at this point. So we'll pretend that DJ's been tuning out all the stuff on eyes and all the imaginary stuff. So he thought, hey, I saw on my calculator that down near the bottom there's this blue button that looks like an eye. I'm going to use it. So in his calculator he said -4 plus second square root 6 second I. Look, he typed in what we have, -4 plus square root of 6i. And then, instead of just leaving that on his paper, he decided to type this in his calculator and get some weird decimal. Do I want that? No. But if you've not been paying attention to what we did with all the I's and I squared all that, would you probably give me that? Yes. Am I going to know then what's been going on with your life? Yes. So literally, our answer is -4 plus or minus the square root of 6i. What does that mean about our graph? What does that mean about our graph? Doesn't even hit the x-axis at all. If we were to graph this bad boy, and I don't know what he looks like, so I'm not betting anything that it looks exactly like this, but he better not touch the x-axis at all, because if we're involving I, that means there are no real solutions, which means we better not cross that x-axis at all. So if you get an answer with imaginary numbers, you better graph it and see what's going on. And make sure it doesn't cross that x-axis at all. Okay, let's do number 2, and then we'll talk about what I need you to do. Number 2 is going to be a fast one. It is still just a medium. I get you don't like the 13. I'm still going to do x squared minus 13x plus something equals -36 plus something. I'm still going to set it up the same way. I'm still going to do middle divided by 2 squared. But I don't want a decimal. So instead, when I do in my calculator, when I do -13 divided by 2 in my calculator, instead of saying -6.5, I want the fraction. So math frac, change it to a fraction. I don't want a decimal. I want a fraction. Math frac turns it into fraction. Press the math button, press frac, turns it into a fraction. But I've done middle divided by 2. I still haven't squared it. So if I square it, no, there's not. If I square it, I get 169/4. So again, I'm going to do it right now too, the other way. So I could have done -13 divided by 2, and then squared it, and then pressed math frac. That's what she's going to say. And that's fine too. As long as you're going to tell me 169/4 instead of 42.25, we're good to go. So again, back to my problem. I'm adding 169/4 to both sides. I promise you, if you put 42.25, you're going to lose your points, 1. And 2, you're never going to reach an answer after that anyway. Why do we like the fraction 169/4? They're both perfect squares. 169 is 13 squared, 4 is 2 squared, so it ends up being nice. Okay, and now, again, if you want to persevere and actually change 36 to have a denominator of 4 so you can add those, that's great. I did that on my paper because I'm a math nerd. Do you have to? Absolutely not. Instead, your calculator is so genius, it remembers what you last typed in. So if you'll just press plus and then -36, it knows to take your last fraction and to add a -36 to it. And lo and behold, it tells me the answer still is a fraction, 25/4. I didn't actually have to find a common denominator or anything. My calculator did it for me. It's 25/4. Okay, but 25/4 is still beautiful. Because if I take the square root of both sides, which I'm going to do because I've got to solve, I'm going to have x minus 13 over 2 equals 5 over 2. And then plus or minus 5 over 2. And then someone first period said, are we done? Are we done? No, I've got to add 13 over 2 to both sides. So it's x equals 13 over 2 plus or minus 5 over 2. And then at this point, yes, you can ask your calculator to add 13 over 2 plus 5 over 2. Or it's really not that deep. 13 over 2 plus 5 over 2 is 18 over 2, which is 9. But if you want to put it in your calculator can do it. 13 over 2, so I did the plus, now I'm going to do the minus. Minus 5 over 2 equals 8 over 2, which is 4. And again, if I were to graph this, my graph better cross the x-axis at 4 and 9, or else I am crazy. Yes, dear. Are there any questions about that? Flip to the back page. I'm going to leave you 3. Which 2 are not yours? Well, obviously that, but on the back page was 2 of these. Because those leading coefficients are not a 1. So instead, we're going to do, thank you, dear. You can keep it if you need it. Instead, we're going to leave you 7, 9, and 11, and I'm going to tell you the answers right now. Number 7, I'm going to call it a medium. It's only a medium because that 1 is not a nice, pretty number. The answers are 2 and negative 3. I'm going to check 7 through 10 at the end of class tomorrow, so it'd be wise to write this down. 9 is an easy, although it does involve imaginary numbers. So the answer is actually 3 plus or minus 4i. Number 11 is not hard, but it is not quite a medium either. So I'm going to call 11 a medium plus. Now the only reason it's a medium plus is because 1, that 3 in the middle means it's not a pretty number. Whatever, I'll give you the answer to 11 tomorrow. It's fine. It's fine. Try 8, 7, and 9 and be brave. There's a checkpoint tomorrow as well, so you got to do something. And I mentioned the quiz, so Jesus, take the wheel.
You said 7, 8, and 9.
Yeah, if you want